So in today's video, I'd like to show you how you can use OVMS for reverse engineering, focusing on how OVMS can be used to pull out what we call OBD PIDs. So what is an OBD PID? Well, PID is an acronym for parameter ID, and that to us means it's some data that's being stored in an ECU. So for instance, the BMS might be storing the voltage of the main battery of the car, and there's lots and lots of these data points all within the ECUs of the car. They're going to hold things like function data, such as say the 12-volt battery state. They're also going to hold things such as like software numbers. So what version of software is running on an ECU is quite important if you're looking to run a software update, for instance. And you need to know three things to use an OBD PID. So you need to know the address of the ECU, so where in the car you're trying to pull this data from, the PID itself, so the ID of the data you're trying to pull, and also any conversion factor. So if you're storing data on a car, you're going to be storing it in kind of hexadecimal data. It's a good idea to apply conversion factors to reduce the amount of data you're storing. So the first step in reverse engineering is to find the addresses of the ECUs. ECUs are going to sit on diagnostic addresses, so they're going to have a CAN ID for diagnostics, and it's usually in the range of 700 to 7FF. And when you query an ECU, they will respond on the query address +8. So if you've sent something to 710, it will reply on 718. And there's also a unique address, 7DF, and that is a broadcast address for all the ECUs. So you can ask every single ECU to respond to this query. So how am I using OVMS? Well, what I'm going to do is I'm going to send a query to the car on the broadcast address of tester present. Every ECU should then respond to my message. So how do you do this with OVMS? And I can show you. So your first step when you want to send data from OVMS is you have to get into a state where the OVMS unit isn't querying any data to the car, and the car's running, and you need to make OVMS go quiet. So we can see here, if we log in, currently OVMS is operating on the car's responding to data, everything's up and running. That's great, but it's not the state that we need the car in. So what we need to do is configure the vehicle, and we can set ourselves to empty vehicle, and that will stop OVMS sending any more queries to the car apart from the ones that we wanted to say. So now if we go to shell, there's currently nothing going on. Everything's all gone quiet. So this is a good state to have the car in. Now, because we've set the car to empty vehicle state, it's actually going to do a couple of things that we may not want it to do. Firstly, if we take a look. Oh, okay. This time the CAN network has remained operational. But what we need to do is actually stop it operating on CAN 3. And that's because CAN 3 is the CAN network for OVMS that connects onto the heads-up display. So it's not one we want to use. We are operating correctly on CAN 1, but just in case you aren't, I'm going to show you how to do this. So we're going to space there, stop CAN 1. So just in case your CAN list is Well, it's not working the way I expect. Anyway, that's a command that should be run to start the CAN bus to be active. Clearly, it's working correctly right now, just as is, which I didn't quite expect, but okay. Right, the next thing I'm going to do, no, you don't need to do this on this for most use. It's just to switch off the heads-up display. And that's because I don't want to see any data coming back and forth from the heads-up display. So that stops the heads-up display being powered. Right, our next step is to start the logging of the CAN network. So to do that, we run this command here. So an unrecognized command. Reboot my I'm going to leave this here. I know it's a bit of waste of time, but it goes to show that OVMS is very much free open source software, and it does have its quirks. But this process I'm going to show you now will function correctly. Just takes a little bit of time to get going, really. Here we go. So we're back online. Should get the status of the car. It shouldn't know any data. It knows a bit. Must remember what the 12-volt battery is, but it knows the rest of this isn't working. And if we go onto the shell, it's not doing anything. So if we do CAN list, there you go. The CAN one is off. So the other thing we want to do is the 12-volt power option. So switch off the external 12-volt. Right, and now we want to run this CAN command. Now we want to change the CAN command here to active, and that's because we need to send some data. That's not no idea what was the difference between command and my one. CAN one start active. I don't know. It was not happy. Okay, there's the command, and now we've got the CAN network working. Now we need to send a command to the car, and the command is quite simple, really. It's a command that says tester is present. Now I just need to check what that command is. Okay, so now we've got the CAN bus in an active state. If we do CAN list, we should see that CAN1 is active in that state. The next step we need to do is start the log file. Now the log file is started by looking at the OVMS page for CAN bus login. I'll bring that up. So here's the CAN bus data logging. It can be used as a data logger. All the information's here about what we're doing today. I'm just showing it to you in a way that we're getting this set up. So it can log to a computer, but I tried this by viewing it. It's just very effective. By viewing it through SavvyCAN. The latency is too high. The SavvyCAN software seems too unreliable on Windows at least. So I think the best way to do it is to log to the SD card. So I'm going to do this as CAN demo and start the logging. It really doesn't like me copying and pasting commands today. It's CAN. CAN log start. VFS. VFS is part of the file system being used. This is a file type CRTD. So VFS is save it to the virtual file system. And then the location is SD card, because I have an SD card inserted, which you need for this, and CAN demo dot CRTD. There we go. Cool. So we've now got CAN logging working. So our next step will then be to send the command. Now the command we need to do is we need to CAN1, as we're sending it to the first CAN network. Transmit is TX standard. So this is a standard frame. And then the address is 0x7df, as we discussed before. And then the command is 023e. And then what we need to do is pad out the rest of the 8 bytes with zeros. So 1, 2, 3, 4, 5, 6. Now that should have sent the data to the car. We then do CAN log stop, so we can check what the data is. Now to see what the data is, go to the editor window, SD card, and CAN demo. If we load that, we should see the data so the log file opened. We then see the data I sent. See it's sent because it's a T, and then it's an R, like the rest of this. Now if we copy this to something like Notepad, pop it in there, stick it on that side of the screen. Now if I bring up the this is the spreadsheet that I've used before, and I keep up to date with all the findings we get from OVMS. There's an ECU addresses tab. Now what we're seeing here are all the received addresses of all the ECUs present on the car, and you can see we can actually run through and tick them all off. So for instance 718 can be seen down here, and that's the gateway module responding. 728 is over here, and that is the ABS module responding. You notice one of the modules isn't present, and that's the EBCC 78C, and that's because the charge controller is only available when the car's plugged in, and right now the car's plugged in. So I'd recommend someone running this kind of check on an MG5, for instance, and they should be able to take a look at the addresses. And I have a suspicion on the MG5, the BMS is actually sitting on a different address. Now, how do we work with that? We found the, for instance, the address of an ECU. Let's say, for instance, 718.710. How do we check what all the PIDs are on that ECU? So I'll show you that in this next step. So how do we perform a sweep scan using OVMS? So this is a very, very simple method. All we need to do is give OVMS an address and a range of PIDs to scan. Now, the more PIDs you ask OVMS to scan, the longer it's going to take. It makes sense, really, because you're asking it to ask for more data. So, to perform the scan, you type in this command here. And this command, say, if we want to talk to the gateway module, is RE, reverse engineering, OBD2 reverse engineering, scan, start. 1 is for CAN 1, 710 is the address we're querying, 001 to FFFE. And that will go all the way through every single PID that there is. And that will take about, I'm not going to show that because it will take simply too long. What we will show is from 1 to 100. Actually, go 1 to 1,000. So that starts the query, and what we can do is ask it what's happening. Scan status will tell us. And you can see here it's collecting a lot of data from the car. So we're up to 100 and something, probably. And there you go, 321. Tells you where we are. So this will run quite nicely in the background, and we'll be scanning all of the data from that ECU. And when it completes, it's almost there, it's at 700 now. When it completes, what we get is a very nice, well, it's so close, a nice list of all the PIDs and all the responded data. Very close. There you go. And now the scan's complete. And we can take this data here and start using it in our reverse engineering. And what we've got on here is a list of all the PIDs for various ones of the ECUs, and that's quite handy to know. So when we've finally identified which ID that the BMS is sitting on the MG5, we can then use this data to try and reverse engineer out of it what the values of the signals are. Now I'm going to go straight on to the final section, which is the conversion factors. So how do we know what a conversion factor is? And this is kind of the challenge. Sometimes data will just be stored in an ECU directly. For instance, here, 0112, I've always seen this as a 12-volt battery state, and it's the value of the 12 volt times 100, so 13.8 volts here, which would make sense because that's where the battery sits when it's on charge. Another one here is the actual battery pack voltage, and we've worked that out to be 434 volts from this 1738, and that's a divide by 4. So you can see the conversion factor is 0.25. Some of these I got from a diagnostic tool, the launch diagnostic tool. Some of these we've just guessed at. But essentially, once we get the list, we can start doing it. One of the useful PIDs that everyone should know is this F183. And F183, so far we've seen it respond with the name of the ECU. So if we get a complete sweep of any unknown address, hopefully on F183 will be some hint as to the nature of the ECU. So we've been seeing it being stored in the hex. You convert it to an ASCII text version, and it's telling us what the ECU is. So onboard charger, converter of some sort. Not always. It doesn't work for the VCU, the vehicle control unit, but it worked on some of the others. So yeah, I think that's pretty good brief overview of how to use OVMS in quite a clever way, and more than happy to answer any questions on either the Slack group or the discourse group if you get stuck along the way. So thank you very much for listening, and please do continue to contribute towards further development on the GoFundMe and PayPal pools, which are both available on the discourse group. Possibly I need to do another post, don't I? I've been updating a lot of stuff. Fundraising progress. So they're all available on this here and on the PayPal pool. Thank you again for listening, and look forward to what you find out.